Welcome back to DS3 Podcasts. My name is Cindy and I'm an online content writer here at DS3. Today I'm joined by Professor Shlomo Dubnov.
Hello.
Thank you so
Hi,
much for
thank you
joining
for
us
having me.
today. I was wondering if maybe you could start off with some background on yourself and how you got started in
Sure.
this really interesting field of music and data science and computer science as well.
Sure. Well, again, thank you for having me. Yeah, I love talking about this because I think this is a super interesting field. Um, that, of course, each one has his own personal history and story, how, to, how I got into this. By training, I would say it was more in the, I was always doing music and sciences in parallel. And I would say it occurred to me that you know, of course, there's the connection between creativity, music. Music has a lot of structure and rules in sciences, but actually to make it explicit, I can combine this with an actual research and profession, if I could say. That's actually how I ended up in UCSD. But I would say I've been really interested in this aspect though, because besides me being trained, actually I started from physics and mathematics in my undergrad, and then I did more of electrical engineering. Um, so I was always doing music, could say it's a hobby, pretty serious hobby. I was playing the piano many years. Then, at a certain point, I switched to studying composition. But then, actually, I was already having a second degree in engineering. I decided I want to go back to music, and I did my bachelor's in music.
I see.
So, um, and that was in theory and composition.
Yeah.
And really, I mean, like it was kind of just the two passions, I would say. One more analytical, one more artistic, and that I was pursuing in parallel. And I was lucky enough that for my PhD, actually, which was in computer science, doing a lot of mix between, my advisor actually comes also from physics, or statistical physics, which, well, frankly, if you think about the Nobel Prize that uh, was granted in AI, it was given in physics.
Wow.
Right?
Yeah.
So I think this whole idea of the relation between intelligence and rules of nature, okay, it's I think so. I guess we'll talk at a certain point about why data science, right?
Yes.
But I think that's a unique intersection because I think each discipline, you know, computing, electrical engineering, and then physics, for that matter, actually try to deal with the world in a slightly different way, and music as well. I think
Yeah.
music is a way of thinking about the world. It's a way of expressing yourself, but it always has some kind of reference to something, to things that happen to you, things that you want to describe that happens outside there. And music is also a communication medium. So I would say I made this kind of a circle going from sciences and my passion for music into actually being focused on music, and then kind of combining this during my PhD postdoc. There was a period I was actually um, came back after postdoc and was in communication engineering because I think actually the way I like to think about things we'll talk about in data science is really through the prism or from the view of communication. So information theory and stuff like that. And so I think both were kind of a possibility of thinking about stuff. And it just happened to me that I was lucky enough, and also, when I was kind of invited here to the music department, and we have a computer music area, suddenly I could really turn both topics into my main profession.
Yeah.
So I don't know if I can say that my hobby became my profession.
Yeah.
But I think that's the combination that I kind of followed through life trajectory. But I know people ask me sometimes, have I planned it or how to plan for something like this? I cannot say that.
Yeah,
I mean,
it just happens.
it happens, but you need to have passion for fields, for interdisciplinary stuff. I think it always helps to have your interests in several things because that's a complete, keeps your own life interesting.
Yeah, I see. I guess for people who might not be as familiar with this intersection or know too much about, because I guess my experience is someone who's like, I played around with music generators and I've seen videos and stuff, but I guess I'm not too clear on like, I guess I'm sure it's like broad and there's like a range of how, audio mixes with computing. So what type of work do you do with that and like, or what is like a general overview for someone?
Yeah, no, it's an excellent question. I think now it became very popular because of also, the industry is exploding, the investments in generative AI in general, and specifically, the visual and in music. So suddenly it became, all over the place.
Yes.
And not only it's accessible and people can use these tools to create music, which is really professional production level, and also, and we have several. I mean, it's an ongoing debate. I mean, what's the role of music, AI generated music, whether it's going to, make the music more creative or it will take away jobs. But I mean, we can talk about this kind of separately. But the whole idea, I think, of using technology as a tool for creation in general and music in particular has long history and legacy of building tools.
Yeah.
A lot of this was building instruments, electronic instruments. But at the same time, it's in parallel. Once the computers started being able to produce sounds by just simulating sinusoids, right, and then plugging them into some kind of a playback device. And at the same time, there were also people trying to analyze music as, I would say, language in a sense of like sequence of symbols, structures, Markov models. So these two interests about like music as an instrument, but also modeling music or creating new instruments for the musicians, but also creating tools that will kind of a little bit lean more towards composition, I would say, or generating the contents and not just the sound. I mean, that exists from the early days of my class years and Bell Labs. We have mostly seen this in the market as synthesizers.
What is that?
Well, I mean, these are basically instruments that are synthesizing sound, right?
Oh, is it like
yeah, like
synth?
Yeah, like the keyboards. Yeah.
Okay.
Stuff that you plug in, modules that you can kind of plug in and suddenly have like you press a key, you have an orchestral sound, right?
Yeah.
So, so the idea was like, okay, so you have to generate notes, and we're always kind of touching on about what's the data science or what's the representation of music, right? So you could say music can be considered as a sound, right? And that's what eventually we hear. But it's also the actions or the notes, the actual musical score, or the actions that somebody does when he plays a keyboard. Okay. So these note ons and note offs and timings and what we rewrite as a score, that's kind of the symbolic part. That's like the text. So there's like text and speech. So you have the score and have the audio. But unlike written text or what we call today with language models, you could think about the same thing, and we have works that actually do that. Is actually apply the same kind of LLM ideas to sequences of symbols which represent notes. But there is something very interesting about the difference between language and music, which we'll talk about. That music actually has multiple staves. More dimensions, it's less, the semantics is not clear, the meaning, right? But also it's in a way, and we'll maybe jumping here to the idea that usually music is written for multiple instruments, which you can consider as some kind of agents, if you wish now. I mean, that became a very popular topic. So it's kind of a multi-agent structure. So when you look at different voices, it's true that you can treat them as one big kind of data stream, but if you start to breaking this into like how musicians interact or the voices interact between them, I think this is a lot of the things that I'm interested in right now, because that makes the whole communication thing come out more.
So basically, how to break music up into a way that can be interpreted.
Well, so I've been doing a lot, and that was sort of my main kind of attraction. I started actually more from the signal processing side, and during my doctorate, I was really interested in orchestral sound, timbre. I mean, what actually makes us so attracted to sound, right? As every kind of practical research question, eventually you define something which might be very narrow and not as, not as exotic. Right, and people still working trying to analyze timbres of musical instruments and characterize why things that might sound, well, we're getting a little bit technical, but there's some interesting aspect of how, let's say, timbre of a trumpet versus timbre of a violin. If they play the same note, okay, and then you can even equalize them to look the same spectrally, you still feel that they're not the same. And a lot of this in the little jitter and the variations and what happens in harmonics, which is kind of a specific aspect of analysis, statistical analysis of sound. So I was doing that, but I would say my main passion, that kind of also was an interesting segue from things that I was doing, really related to more of a communication kind of a side, using compression algorithms, was thinking about music itself, not just the timbre, but like the sequence of musical notes, and music in general as an information source. Because music is a message in a way, like language. And then if you think about theory of information channels, the three theorems or three I don't know what to call them, laws. I mean, the whole idea is you don't treat an individual message as something fixed. It's just an instance of some kind of probability distribution. You generate things, right? And they have structure. That's why there's a lot of redundancy. And that redundancy can be also manifested in the way it envelopes or develops in time. And that's why LLMs are actually predictive. Right?
Pretty good.
So doing these models that actually capture the structure in music, okay? And you can think about one use of this, which is compression. As I said, I mentioned I was kind of teaching in communication engineering, the information theory, and stuff like that. So the whole idea is if you find a good representation, which means you actually know how to create a very complex representation, a code book, then of course you can compress, but then you can sample that code book, and that will create another instance from the same information source. That's very conceptual.
What do you mean by code book?
Well, code book would be, it's a technical word, but it's in some compression methods. You basically encode sequences in some way. Okay? And then you basically just transmit the index to that code book. And then the receiver has the same code book, so you can decipher this. But if you share these code books, okay, then what you have to transmit is very little. Because what you do, you encode long sequences with short indexes, and rare sequences, okay, you can give them a lot of bits, and that's how you achieve compression, basically. So all these rules about, you have information source, you can compress file to its entropy, you can error correct and stuff like that. That comes really more like electrical engineering, information theory, which is kind of where I feel most, and the kind of the physics of it. Right? Now, if you think that, the messages are basically, even now, I'm generating random sentences. I mean, they make sense because they're in the context, right?
Yes.
But I guess you can predict a lot to say, at least on the level of the next word that makes expression. And even the fact that it makes sense is that because you kind of like managed to chain this into some kind of a thought that makes sense to you. Because, not only English, we're talking about some technical terms. So if you know them, probably that gives you more context, right? If not, I might lose my audience, right? But just I think the idea that we are very used now, like LLMs, that they actually, the power is action, prediction, right? Speaking on physics now, diffusion models, which became very popular in generating images, but also with sounds, and they also have their own kind of dynamics. There's noise that kind of you try to remove it. So there's something interesting, and this is, I'm not getting about prediction in time versus some other technical aspects, denoising steps. But I think the whole idea is that you kind of transmit information by realizing that you're sending one out of many possibilities. And then if you have this nice representation, that means you can also use this as generative.
Yeah.
So if we go back to this idea of a code book, which I think is kind of, at least for me, it was more intuitive. So if you manage to encode structure in some kind of code book or a tree that captures really the salient messages, motives, then you can do a random walk on that structure, you can sample that structure. And then you'll create another instance from that information source. Now, that instance means that, it can actually generate music with sort of the same structures, but it's not going to be exactly the same data, string that you analyze.
Right, it'll be a bit different.
It will be some kind of a variation that maintains statistics.
Nice.
Now, why this was interesting musically, I think this is maybe part of the motivation. And I know, like, in the questions, you wanted me to talk like why data science. So I was kind of thinking that context, but maybe I'll let you ask the questions about, like, why music and data science? Because I was kind of just saying that now people are aware of the fact that you can generate these random, frankly, sequences of either notes or sounds, signals, okay? And they sound like real music.
Yeah.
But they're random.
Yeah.
It's just that all the structure is already encoded in some kind of a very big model that knows all the redundancies, and now it can kind of do variations, right? It can sample in different ways. Of course, you want to guide this towards something, so you do text to music.
Yeah. You say this genre.
Right, or this emotion, or even give lyrics. And I think that's really mind-boggling and amazing. And frankly, for me, it's more like, me witnessing some kind of a miracle happen. But I still stay loyal in a way, at least that's my understanding of this whole process, is that we are still modeling an information source, okay, which means some kind of a magic box with a lot of possibilities. And every time we open that box, we get another genie out.
Yeah.
But it's every time different.
Yeah.
And I think this is what we now have as these tools. Now, as a user or as a listener, if we attribute intelligence to this thing, or creativity, which is even more difficult to define, well, that's because this is the way we would understand this if a human being were
create their
creating.
Yeah.
Right.
Like
and I think this also gives us like a lot of stress.
Yeah, for sure.
Because it means it takes away a lot of our
autonomy.
Not only autonomy, I mean the sense of self-esteem.
The pride.
The pride of being human, right?
Yes.
I mean, I have all these, these wonderful capabilities that I can create, I can express myself. People fall for, they get excited from my creation, and then some machine does that, maybe even better than me. So where am I?
Yeah, where do you fall in that line? Like where do you see?
So I'm still a little bit into this idea that we are developing tools for humans, okay? And I know that today most people kind of see the generative music, generative AI as a threat because of the way they treat this or the way it's being shipped to the market, right? as a tool that allows you, like in one shot, with a simple prompt, get a whole piece, and you're done.
Yeah.
If you think about the same technology being wrapped into more like musical instruments, or like agents, or something you can improvise with and interact with, then I think it's totally different game and ballpark of what you expect from these things to do. So in that sense, I think AI, generative AI, as some kind of a companion, that's something that, and also the things we were doing before, now everybody switched to doing deep learning, these models, generative AI. We're doing much more naive models, which are still generative, but not with these huge neural networks. But the idea that you can make the machine generate music in a way that basically is an improvisation, and if you can do this with the humans, it becomes just as another companion. It could be, of course, either parroting you, but it might be doing something which is giving you new ideas.
Yeah.
In that sense, I think it's an incredible tool.
Yeah.
It's just that, if all you need is a song of that duration with this mood, with specific genre and specific instruments, and you write the prompt, you'll get it for free, and you don't need the human for that. And I think this actually creates a very interesting challenge to understand. So what will be the advantage of the human and the value if the human has to create these songs? Because the listeners, in some sense, if they're not very, I don't want to say educated, because educated sounds really but if they don't have the sensibility and the keen interest in a specific artist and a specific way of expression, and you just need the music to fill your background, and again, that really depends on the quality and what you expect and how carefully you listen to what's going on. But AI can fulfill that gap. And as we see today, I think from some, I'm not into like economy of music, but they predicted almost quarter of the music revenues in a couple of years would be AI generated, and it's I think it's going to be like $4 billion out of $16 billion of the music market. And even today, I think people are uploading en masse AI generated tracks.
Right.
Companies are kind of trying to stop that or remove some tracks. But I'm really interested in those musicians who actually take this technology and work with it to make it their own.
Right.
And there is a community like that. There was always an experimental music community that was experimenting with new sounds, with new instruments, new ways of composing. And now people are doing this with AI. But those who are really interested in AI, they can spend 2 weeks prompting AI until they get the song they want.
Yeah.
And they do little edits, and they play with it, and they, a lot of these companies now come up with studios, which means you have multiple tracks. You can play something, it'll give you other tracks. You can edit them, you can ask to cover another song.
Yeah.
So it becomes really like, your companion, musically knowledgeable tool that allows your self-expression. And then you can build your own name, you can build your own brand.
Yeah.
Because usually when people ask me, so what's going to be AI? AI will replace the musicians. I'd say, well, can you become a real musician using existing tools, in the sense that people will recognize you, your own style? Can you create an album that tells you whatever?
Using AI.
Yeah, usually your own.
Yes.
There will be something that actually is not just a set of cliches.
I see.
It's really your expression. So how do you fine-tune that AI to be yours? I think that's the next thing. So when you ask me what I think about this, I think this is what will make AI meaningful and will become a tool that actually encourages creativity and self-expression. But it will be also, the way you use it, in the most naive way. If you don't need anything from music besides just filling up some kind of a sonic gap. That sounds great.
Yeah.
You have these tools, right?
I'd love to get into some samples if you.
Right.
if there's
Okay.
any.
Sure.
Well, I know
yeah.
that you worked on your own project too, or was it I
Right.
read poetry too?
So I think one of the aspects of trying kind of to make this interactive and make this expressive is actually working with human creators, with poets, with musicians, and I think that also brings out this idea that that AI that we're trying to build has to be responsive. In a way, it could be responsive in the way it writes the music and somebody performs, but it's responsive in the sense that you even treat the voices as kind of agents that have to have a dialogue. And I think this is also something that I really love kind of teaching in the music classes. And the idea that music is really not just a sequence of sounds. If you think about the role of music, it was always kind of had its social role. People would perform music, it could be in rituals, it could be in events. Even when you go and you listen to a concert, you kind of actively participate in a way because you have to actively listen.
Right.
So in that sense, music is actually not the music itself, it's the act of participating in the musical experience. That's sometimes people call it musicking, the act of doing music.
Yeah.
So in that sense, if you think about music where you have multiple voices and they kind of talk to each other, I think that dialogue is what actually makes the music interesting, not just the harmonies and the rhythms and melodies. It's not a theory of music, it's actually what's behind it. Exactly. And so when you compose, you can think about this, or if you go on stage and you improvise with a machine, you want it to be interactive.
Yeah.
So I brought some examples. I don't know how well they will translate to the
They're
recording.
loud enough,
But I was thinking, well, I don't know if you want to start more classical or mellow and then go to radical.
Sure.
Okay?
Let's do
But
that.
I brought 3 examples. So maybe you can start with an older example, which is really just 2 violins.
Okay.
But it was generated with our older algorithms, which were based on really compression methods. Actually using kind of version of, well, there's the Lamp-Ziv algorithm that is used for compression. Then there was some other string matching algorithms. But then you create a structure and then you kind of randomly sample it. Okay. Now, these structures were based on existing pieces. But what I want to show is not only that, each one of the, so this is, what I'm going to play is something from, I don't remember, it's good decade ago, okay? Early on when I came to UCSD. I've been here for 20 years now.
Wow.
So this is a duet for 2 violins, okay? And actually, violin and viola. Now, each one of the voices was modeled separately, but also the relations between the voices were modeled in a way that, one voice would be randomly generated from a model that was based on analysis of several musical pieces. And then the second voice could also start randomly, but we try to see how these 2 voices interact in relation to these pieces. And they had kind of a preference to try to go and follow the predictions where they both play together. But if that didn't work, they would kind of go randomly off until they hit together some kind of a joint probability. So you actually have to model each one separately, and you have to model both of them together. And by going into these kind of like coherent and incoherent passages, I think that was something that was trying to also take advantage or use this idea of this kind of a trade-off between being totally independent, just talking about whatever you think about, being attentive, then breaking away and coming together. So this is kind of a classical example, and this was generated. The score was generated by a computer, and then was given to my colleagues Janusz Legacy, who passed away, and by Wiki, his wife. So let me play a short excerpt. This is called Composer Duets, and this specific piece was based on different composers for Brahms, Schumann. So Janusz Legacy by Wiki, linktr. So I think just to give an idea, okay, but maybe you're not so used to listening this way, but I'm sure you could have noticed there were moments that were kind of like each one is taking more liberty. And then one would basically take the lead, another one kind of try to shift to hold the notes, and then suddenly they are playing together. So one moves out, and then they kind of like there were places where we're really not synchronized. Now, this is a random process again. I remind everybody, remind the audience, this is a sample from a random, it is a random process that was kind of done by analyzing several classical pieces and creating some kind of it's actually some kind of graph, two graphs and a joint graph. And then it's a random one.
That's so cool. Oh my God. I think I didn't realize how because I think my perception was this is a field that really started recently, because that's when I started discovering generative music. But that's I can't believe that was 10 years ago.
Yeah, well, I mean, and there were people exploring this way before.
Yeah, wow.
So this is kind of maybe also using much more naive techniques, but they did have this element of attention, if you will, because there was this kind of a graph that tried to look up previous sequences that reappeared and you kind of remix with them. So so this is one. Shall we go to more radical example?
Let's do it.
So here's another example of a work, and this is also in collaboration with my ex-graduate student, Kechen, who's now in Adobe, research in Adobe. It combines kind of several technologies, if we're interested in that. Actually, we already had at this point, and this is from 2 years ago, we had our text to music using diffusion. So we used that. We had a previous, and this is kind of a long tradition of these improvisation systems that were based on very similar algorithms like these violins thing, but they were actually working in real time. So this is a collaboration also with the Institute in Paris. So I'll tell a little bit about the technology, okay, and not to go too deep, but kind of so this madness makes sense.
How
Right.
Yes.
And then I had the opportunity to work with Soundboard in Jaap blog. Now, for people who don't know what sound poetry is, I think that's a fascinating kind of way of making art. This is creating poetry, which is basically like mumbling or babbling, or I don't know how to say, not mumbling, it's babbling in the sense that there are no words, or words that don't make any sense. Okay, and sound poetry is basically using that kind of just the emotional and well, there's the aspects of creating vowels and sequences as if words that actually don't, Jabberwock. Okay? Lewis Carroll, that's maybe kind of, and that sounds more like English than some of these sound poetry events or compositions and creations. So Yablong is a sound poet. He performed. He gave us actually his poetry, which is, and I know the audience won't see the text, but one of his poems was like PR exclamation mark add sharp PR $ percentage PO I don't know head and star.
Yeah.
So it's like okay. He is amazing at performing this, and it's actually super impressive. Now we actually asked the AI to interpret this and create some sounds based on this.
Yeah.
Not exactly what you do with sonnet audio. I mean, you can try to put sound poetry, nonsense text, but actually this text has a lot of structure, has repetition. It uses the idea that it might be explosive and rolling and then and stuff. Okay, so there's this aspect. Amazingly, of course, now AI can interpret this. It gave us a lot of possible little renderings of this thing, but we wanted to perform live, so we actually chopped it up into a bank of possible sounds. We load this into our improvisation software that actually can now also kind of play back random segments from this, where it's driven by some of these sounds from the microphone. So it also makes it interactive. So both the background music is generated by AI, and the interaction is controlled by another kind of AI, and that's kind of the improvisation here, which is maybe based on older techniques that we have. So so I'll just play a short segment of this performance. You can hear. So you'll hear Jablong, his voice, and then the background sounds and how they cut off and are re-triggered based on his sounds. And of course, it was a whole collaboration also with other composers and performers. Churcher Block was controlling. He's a French composer, and I was with him there, and he was controlling the improvisation software. So here it is, okay? Here. Correct. So that was a longer reason. It was like 10 minutes. It's just but it gives you an idea. Regardless of whether you think about this as some kind of crazy experiment in music, we have this sequence of a series of improvisation technology concerts with my colleagues in here coming Protect. But this is another example, okay, of how this technology can be used totally in a different way. Okay, so maybe you can throwing some ideas which will basically argue that this technology is really opening up possibilities.
Right. That's so interesting. And it was kind of used as like a background for like the real, like the human piece, I guess. Of the human who's performing. And I've never seen it before.
Sound poetry.
Yeah. I've never seen it. I've heard of that.
Check it out. Yeah, no, it's a lot of fun.
It's so interesting because it's like behind him, and I'm sure like we will put this on the screen for the video. But it's like I would never. It just like looks like gibberish, but when you hear it, it's like creating this like coherent like string of.
No, it's very, very, very emotional, very touching. Yeah. So it also kind of gives a question because this is text which has no semantics.
Yeah. Well, it has meaning, but not semantically. Right.
So it's a sequence of basically symbols, right, or signifiers.
Yes.
Right? But they have no significance. Think about language, right? Language is signifier, but it doesn't mean anything, right? So, do we have time for Maybe one more?
Yes, let's do
Yeah.
one more, and then I guess I can do. Yeah, I can. I think we have
Yeah,
time. We have time for one more. Yes.
Okay, so I think one more example that I brought today is from another use of AI, which combined, again, the same text to music technology to be developed in diffusion models. Uh, but we also used ChatGPT, the visual ChatGPT. Sorry.
No worries at all.
Just turn it off. I didn't think about this before. Sorry. Just make sure it doesn't happen again. So, yeah. Sorry, to my viewers.
No worries at all.
So, and so we actually used visual intelligence, right, to ask AI to interpret several graphical scores. So now again, it could be, maybe I could see me doing like some radical art here, but that's, we are in academia, we are the tradition of music department here is really experimenting with music. So things that might be, some might feel it's not music. I mean, it's totally fine, right? This is expressing self. This is music. And this is actually participating in the act of making music, no matter exactly if this is a specific genre style. If you know what chords mean or what are rhythms. I mean, this is kind of really just an abstract way of thinking about communicating with sounds in artistic ways. Okay? That's also one message for people thinking about music. Open it up. Anything sonic.
Yes, is considered.
That actually has a meaning,
Yeah.
has a structure and meaning,
Yeah.
is a musical expression.
Yeah.
Okay. So, so here we actually took scores, so-called graphical scores by an English composer, Cornelis Cardiff. And I don't know if you're going to put visuals eventually for the podcast, I can send you some examples of the scores.
Okay.
No, the score. But these are basically lines and circles and triangles and all kinds of really abstract expressions that can convey, and again, questions how you read this. Okay, and musicians are actually interpreting these things in very different ways.
Right.
They actually sit and they rehearse and they agree on what it means. It's a little bit like Kandinsky paintings. I don't know if you know Kandinsky, but it's kind of like lines and things. But they're black and white, not color. But they convey something. They convey this movement and gesture and collation and stuff in a very abstract way. So we actually asked the visual aspect of ChatGPT to interpret this into text, which had kind of this musical interpretation. Give us a rendering of this, and then plug this into our text to music. And so we used language as a bridge.
I see.
And then we basically went like chunk by chunk through his pages, okay, because his score is 100 and some pages. We used 30 out of it, and each page was kind of cut into several pieces, and tried to make this continuous, and asked ChatGPT basically to perform it.
Okay.
Not ChatGPT, sorry. We asked ChatGPT the visual to interpret this, and our diffusion text to diffusion to make the sound. Okay, so
it kind of went through two different transformations.
Yeah, and we actually had it performed in a concert where we had also humans do their version of the same score.
Oh.
Yeah.
Could you tell a difference?
Yeah, well, I mean, it wasn't the same.
It wasn't as good yet.
Well, when humans are there, you can see them kind of like trying to communicate with each other. They follow the score, but they actually listen to each other.
Yeah.
And this was also already like a fixed dialogue recording. We did several versions. So let me see which one maybe the string orchestra will be the most conventional one, because we did with sine waves, experimental, but string orchestra version of this Cornelis Cardiff.
That's
Yeah.
really cool.
So the idea is, think about this as prompting,
Mm.
but not with text, not with lyrics, but with some kind of very abstract, graphical expression of your feelings and ideas. This is still far from being perfect, and it also kind of is pretty choppy. We try to make it continuous, but I think it also brings us to some other aspect, which kind of relates to the idea that you want to interact with this AI in ways that allow you to express yourself in ways that don't have to be just text prompt.
Right.
Okay? Can you write a score? But if you don't need to write the notes, maybe you can kind of draw your emotions.
Yes.
Okay.
Yes. Like
Maybe you do like a sonic sketch, like you did with the sound painting, right? You can maybe even compose music and then remove the vocal thing, right?
Yeah.
You want something that goes, oh, bang, boom, boom. Okay. And now it will create an orchestra that does that in a specific style, right?
Yeah.
Now that becomes more of your impression,
Right.
right? And if expressions.
Mhm.
And then if you actually develop your technique of doing this and you make your little sensibilities, what exactly types of renderings you want, and how you deal with it,
Taste.
then maybe you can be an AI musician.
That would be a future profession.
Well, no, there are actually
It
people.
is not me. Yeah.
There are people. I mean, there are actually competitions of AI musicians who do that. True that most of the commercial products like Sonodio, and now almost all the big companies
Yes.
own pieces of this field,
Right.
right?
Right.
Including Facebook and Google, and they usually train this on popular styles.
Yeah.
So most of what you hear would be more of tonal, rhythmical, I would say, generally, right? And not very abstract or experimental.
Right.
But you still can get very personal. It just makes as much effort to make it personal as if it would take you to write this with an instrument and go into a studio. So we're not really saving work here, if you really want to dive into it. It just boosts it up to a level of production and ideas that before maybe you needed many more years.
And experience.
But now you need also quite a lot of kind of sensibility and patience and taste. Right?
That's so interesting. I'm not like I feel like I haven't really ever delved into like this side of music making, but
Right.
yeah. That's such a creative way to have something that's not even text, like a different and abstract, like score, and have that turn into.
And this way, want the machine to be sensible in the way you would, right? To understand your kind of
and know your
expression,
your taste as well,
and kind of like learn your sensibilities, and hopefully, don't throw you off too much. But
okay, we have 4 minutes left, so I guess I'll just end with like some fun questions.
Mm-hmm.
What is a class that you would teach and it can be about anything. It doesn't have to be music related or like it.
Mm-hmm.
It could be like a very cookie or something.
Well, I think I really do that here. I mean, that's one of the advantages of being a professor. You can also kind of customize your own classes. So I would advocate for my Music 5, which is an undergrad class that actually takes this very particular view of music.
Mm-hmm.
Music basically is organized sound to create, an expression and experience. Okay? So we cover a lot of these other things, and now actually, because this class exists already for many years, now we're trying to incorporate more and more AI into it because these tools exist. I'm still not daring to make like a whole AI class about composition because I think, we don't. These are still very experimental tools, and but I think this is one aspect. Another aspect that I'm very interested in, but I'm not really teaching a class like that, is almost like the philosophy of intelligence and creativity in the age of AI.
Like ethics.
Ethics, yes, it's part of it.
Part of it.
Part of it, ethics, aesthetics, but also the idea, I think that, being able to keep your kind of critical thinking while all these tools give you an easy way out.
Right.
And then the question is, what do you need to do in order to internalize the knowledge that these tools offer you
Right.
without being superficial?
I see.
And I think it's kind of the same idea that I was going to try to convey when I said, to become a composer, you have actually to spend time with these tools, with ChatGPT, with other kind of text-based tools. If you're researching a subject, it's true, it can provide you quick answers.
Yeah.
And you have no intuition whether it's true or not.
Right.
You just follow.
Just take its word for it.
Take it, yeah, right, and you dump it at somebody else, right?
Yeah.
But I think, there's this aspect of spending time with the subject matter that you're exploring.
To really learn it.
And get the intuition and get basically the sensitivities, sensibilities, and kind of your own worldview about things. So forming your own opinions and being able. So this other thing that really interests me is, what does it make to a human when you externalize your knowledge to a device?
Yeah.
So same way, you still need to learn the multiplication table to get some sort of an intuition about music or geometry and have these kind of abstract models that you can build one on top of the other. And the fact that the AI can provide you the answers, you will never learn to have that intuition to move to the next step if you don't spend time with the material itself.
Yeah, I really agree with that, especially because I think struggle is something that's that used to be really necessary to get to learn all these skills, whether that be in any field of art or when you're learning a new skill, like writing even. And now it's very tempting to, I guess, take the easy way out and say I don't want to spend all these years studying the subject when this model can help with that.
Right. But think that everybody will be doing that.
Yeah.
So still to stand out, you will need to be the one who actually masters the new tools in a way that is going through you as a human.
Yeah.
So I think that aspect, which is still the class, I don't know exactly how to think about this, but I think because it's really cross-disciplinary, it goes across any kind of use of AI and how it actually relates to our own psychology and maybe even neural science. Yeah.
I guess a final question is, what piece of advice would you have given to yourself as an undergraduate? Since I guess a lot of these people watching, it doesn't have to be career advice. It could be personal.
Well, that's an excellent but also a very tricky question. I don't want to disappoint anyone. When we think about making the right decision and planning and stuff, we're also doing something with statistical estimation, right?
Mm-hmm.
Which means we kind of try to see what's more likely, where what's the better way to get my job prospects or life, whatever. So I'll just quote on advice that somebody else gave me when I was studying music. I was consulting just for earning, right, for life in operational research.
Mm-hmm.
And then, I was finishing my degree in music, and I was talking to my boss, who tried to bus home together, and said, what are you going to do with music, right? I did it for passion, but the job prospects are not great.
Right.
Being a music teacher is very hard.
It's tough.
Life and being an artist is even harder, right? It's such a slight chance. Going back to engineering kind of was my kind of passion. So his advice was, and that's what I'm quoting, he said okay, in operational research, we're doing simulations, we run these things, we do statistics, but you cannot do statistics on a sample of one. And you are a sample of one, which means you can take into account all of these probabilities, but eventually you have no idea how things will turn for you.
Right.
And when it turns for you, it turns to you 100%. You know, it's not like
It's not
80% 50 and then I can, no, that's what happens to you, right? So if you fulfill your passion, then you're fine with this 100% that happens to you. So I think that's kind of the point is, yes, I mean, there's reality and you have to work hard and you have to build your skills, but also follow your other interests and feel that you are happy with what happens to you.
Yeah.
Because what happens to you is 100%.
Right.
And not like chance by chance, right?
Yeah. What a wonderful piece. Thank you so much
All
for
right.
that. And thank you so much for having
Thank
this
you.
conversation.
Thank you. And thank you for having me. And I hope it would be of interest to some.
For sure was for me, and I'm
Okay.
sure that everyone watching as well.
All right. Thank you.
But yeah, thank you so much.